Today we're doing 5.6 parallel and perpendicular lines. Parallel lines are lines that go in the same direction. They're never going to intersect. They're non-vertical lines and they happen to have the same slope. They're going to have different y-intercepts, but they will have the same slope, therefore never intersecting. Perpendicular lines are lines that have slopes that are opposite reciprocals of each other because perpendicular lines form a right angle. So they're going to make a T, they're going to intersect, but they're going to intersect forming a right angle, and their slopes would be opposite reciprocals of each other. So let's say your slope was 3/4. A perpendicular line slope would be -4/3. Opposite sign and reciprocal of each other. If your slope was -2, a perpendicular line slope would be +1/2. So let's look at these questions. What is the slope of a line that's parallel to the x-axis? Well, let's look. If we have our graph, and here's my x-axis, here's my y-axis. So let's say I have a line that is parallel to the x-axis. So it's going to run like this. Well, if they're parallel, right, we know the slope of a horizontal line is hoi, so 0. And if they're parallel, they're the same, so therefore it is also 0. What is the slope of a line that's perpendicular to the x-axis? Well, if it's perpendicular to the x-axis, it's going to go like this. And a slope of a line that is vertical, vox, we know is undefined, so therefore this slope of this line is undefined. What is the slope of a line that's parallel to the y-axis? Well, the red line is parallel to the y-axis, so we already know that one is undefined. And what is the slope of a line that's perpendicular to the y-axis? Well, the blue one is perpendicular to the y-axis because it forms a right angle here with the y-axis. And we already know the blue line, the slope is 0. So just remember your vertical line slope of undefined and your horizontal line slope of 0. So let's look at this problem here. This is in slope-intercept form, y equals -1/2 x plus 5. And we're going to break it down to see if we can find all the different components that we've learned. So the slope, since it's in y equals mx plus b, we already know that the slope is going to be -1/2. Which means my parallel slope, so I have the symbol for parallel right next to it, the two lines, is going to be the same thing. -1/2. And my perpendicular slope, I have the perpendicular sign, which is an upside down T next to the M, which is my symbol for slope, is going to be the opposite of this, so positive, and the reciprocal of 1/2, so a +2. Now my x and my y-intercept, well, my y-intercept I already know because it's in slope-intercept form, so my y-intercept is my b, which means it's 0, 5. My x-intercept is going to be something, 0. So in order for me to find that, I have to plug in 0 for y. So I'm going to put 0 equals -1/2 x plus 5. Subtract the 5. Multiply by the reciprocal. And my x-intercept is +10. So 10, 0. Now this one here, we're looking at the graph. My x and y-intercepts are going to be easy to find because I can see where it crosses the axis. My pen isn't working. So here's my x-intercept where it crosses the x-axis, which is -1, 2, 3, 4, 5, 6. So my x-intercept is -6, 0. My y-intercept is where it crosses the y-axis. So +1, 2, 3, 4. So 0, 4. My slope, well, I know it's a negative slope because, I know it's a positive slope because if I start from the left and I go and I trace the line, I'm going up. So therefore it's a positive slope. And if I go from intercept to intercept, my rise would be 1, 2, 3, 4. And my run, let's put rise is 4. And my run is 1, 2, 3, 4, 5, 6. So my slope is 4 over 6, which reduces to 2 over 3, which means my parallel slope is exactly the same. And my perpendicular slope is going to be the opposite, so negative, reciprocal of that number. Negative 3 over 2. Alright, this one is in point slope form. So I want you to take a second, pause the video, and see if you can solve this in point slope form. Find the slope, the parallel slope, the perpendicular slope, and the x and y intercept. Make sure you pause because the answer is going to pop up in about 5 seconds. Okay, so this is in point slope form. Y minus y1 equals m times x minus x1. So my m, my slope is negative 3. My parallel slope is exactly the same, negative 3. And my perpendicular slope is the opposite reciprocal, so positive, and I flip the number, so 1 over 3. To find my x and y intercept, well, for the x, I'm plugging in 0 for y, which is down here. So if I plug in 0 for y, I just solve for x, and it gives me negative 8 over 3, comma 0. For my y-intercept, I could have also plugged in 0 for x, like I did here, but I could also solve for y and change it into slope-intercept form, y equals mx plus b, because then it would be easy to find out what it is if it's already in that format. So let's look at these. These are determine whether the graphs are parallel, perpendicular, or neither. Well, if you look at this one's in slope-intercept form, so my slope is 4. This one is in standard form, so my slope would be negative a over b, which will be negative a, which is negative 4, over b, which is 1, which means I get negative negative 4, so positive 4 over 1, which is just positive 4. So these two slopes are the same, which means these two lines are parallel. So take a second, try the next two, and see if you can figure them out. Make sure you pause the video. Okay, so since this has a y equals but no x, then it's automatically a horizontal line, hoi, which is a y equals equation. Horizontal lines have 0 slope. This one is an x equals no y, so it's a vux, vertical line, which means it has an undefined slope. And since these two are complete opposites of each other, that tells us that these two are perpendicular. Now here we have one in standard form, so negative a over b, negative 3 over 6, which reduces to negative 1/2. This one is in point slope form. This one was in standard form. I'm not sure if I said that incorrectly. This one is in point slope form, so here's my slope, negative 1/2. Since they are exactly the same, these two are parallel. Alright, write an equation of the line that passes through the given point and is parallel to the graph of the equation. So the first thing we need to do is figure out what is the slope. And in this case, it's in slope-intercept form, so the slope is 3. Y equals mx plus b. So now that I know the slope, I'm trying to find a line that will pass through and will be parallel. So I'm looking for the parallel slope. Well, parallel slope is exactly the same, so it's also 3. To do this problem, I'm going to plug into point slope form. But I'm going to plug into point slope form with this line, with this point, because they said it has to go through this point, and it has to have a slope that is parallel to the original equation. Once I found the slope that's parallel, I'm done with this equation. I don't need this anymore. So I'm going to plug into point slope form, y minus y1, which in this case is 2, equals m. So now I'm going to use the parallel slope because I'm making a new line, times x minus x1, which is 3. And whenever you're looking for an equation of a line, you put it into slope-intercept form. So I'm going to solve for y. Move over the 2. And I get y equals 3x minus 7. So you see the slopes are the same because they're parallel, but their y-intercepts are different. -2 and -7. Okay, look at the next one. The next one says write an equation line that passes through the given point and is now perpendicular. So now when I find my slope, which in this case is 2, I have to find the perpendicular slope. And when I make my new line, I'm going to use the perpendicular slope and the point that's given. So go ahead and try that. Okay, here's the answer to the problem in slope-intercept form. Okay, sorry, this is the answer to the problem. I had used the regular slope and not the perpendicular slope. And you know what cued me that I did it wrong is the fact that their slopes at the end were not perpendicular. Now they are, 2 and -1/2. So I know that this is a line that's perpendicular to this line and yet goes through this point. Here is your assignment from the textbook. So if you want, you can go ahead and keep this page or take a screenshot so you have it tomorrow. I'm sure it'll be posted as well. And that's it for lesson 5.6.